Welcome to the first video in Unit 1, Intro to Functions. On this first screen you'll see the objectives. This is what we're going to accomplish. You can write the objectives down or you can just wait and take notes on each screen. And sometimes I will put in a cartoon or something on the very first screen just to add a little interest. A reminder about function notation. Sometimes when you had an equation, y equals 2x plus 1. Sometimes instead of using the y for this, you can write a function, and that's what f stands for, function. Doesn't have to be an f, but this one is. And then parentheses, and then inside the parentheses you put the variable that you're using within the equation. So for instance, if I had the same thing but I said f of b, that would be 2b plus 1. If I said g of y, then this would be 2y plus 1. So the variable inside here matches. And this is just notation, and it just means the function in terms of the variable that's denoted there. So say for instance on this one, instead of f of b, I put f of 2. Then everywhere there is a variable, I would put the 2. 2 times 2 plus 1 is 5. So f of 2 is 5. And if I wrote that as an ordered pair, I would say this would be the ordered pair 2, 5. Or at x, this is f of x. So that's just some more about function notation, and we'll go over it again. Just on this one, we're going to evaluate, which we've done already a little bit. Okay, here's an example on how to evaluate a function. So the example is if I have the function f of x is equal to x squared minus 2x plus 3, then I want to find f of negative 1. So this is an evaluation of a function. So everywhere there's a variable, I'm going to go ahead and just put parentheses so that I can fill in. This negative 1 is going to go here and here. All right. Negative 1 times negative 1 is positive 1. Negative 2 times negative 1 is positive 2, and then the plus 3. So I have 5 plus 1, which is 6. And so that's all you're doing is, if I wanted to put in f of x plus 1 to the same function, then I would have, here's x squared minus 2 plus 3. That's my shell, right? And then I'm going to take this and put this inside. X plus 1, and then plus 3. And now when I multiply this out, and I could multiply this out pretty easily, the x plus 1 quantity squared would look like this. I'm going to go ahead and use the distributive property, so negative 2x minus 2 plus 3. So this part right here, I'm going to go ahead and multiply that out using a FOIL method. Basically, I'm just going to go x times x is x squared, x times 1 is 1x plus another x plus 1. So I have x squared plus 2x plus 1 minus 2x plus 1. So the 2x and the negative 2x are going to cancel each other, and I'm going to end up with x squared plus 2. Okay, we've also worked a little bit with inequalities, and so I want to do another example on how to solve an inequality. So what we're going to do is use our basic algebra, and we are going to act like this, instead of being less than, is going to be equal to. So this first side here, negative p minus 13 less than, I'm going to use the distributive property, so 15 plus 12p. I want you to work this along with me. If what I'd really like for you to do is to copy the problem down, work it, and then come back and see if you got it right. Okay? So on this one, I'm going to combine these. So I'm going to have 13 plus 12p on this side, and I have negative p minus 13 on this side. On the next one, I'm going to go ahead and I'm going to add p to both sides. And then I'm going to subtract 13 to both sides. Okay, so this one is going to cancel, this one is going to cancel, and I'll be left with negative 26 is less than 13p. Okay, now I'm going to divide 13 both sides, and I have negative 2 and p. If I rewrite this, I could say p is greater than negative 2. So when you write your, this is negative 2, when you write your equation, or excuse me, your graph, I'm going to put an open circle here because doesn't say equal, it just says greater than. And so greater than goes this way, and you got it. We're also going to review absolute value. So I put a problem on here. As you recall, before we set up an absolute value, we have to move everything that's not inside the absolute value to the other side. And so this is a matter of undoing. So I'm going to subtract the 8, and that's going to leave this on the left side. And then I'm going to divide both sides by 2, and that's going to be 3x minus 4, the absolute value of that, is equal to negative 1. Now recall what the absolute value means. The absolute value means that you are looking for two values that are the same distance away from the center, from the origin. So for instance, if this is 3 and negative 3, the distance from 0 to 3 is 3. The distance from 0 to negative 3 is also 3. Distance is always positive, no matter which direction you go, in the positive direction or the negative direction. So when you get to this point right here, what that's saying is that the distance from this part to the origin is negative, and that cannot be. So this is no solution. Another way to write this would be an empty set. There is nothing that would make that true, because by definition, the absolute value is the distance. Okay, but if you were going to do another example where you had the absolute value of 2x plus 1 is equal to 10, we'll do 2 times, right? Then the first thing that I have to do is I have to get rid of or divide out everything by 2, and that's going to give me the absolute value of 2x plus 1 is equal to 5. Now what I'm saying is that I need to find both values. So I have 2x plus 1 is equal to 5, and 2x plus 1 is equal to negative 5. Because inside the absolute value, that could be equal to negative 5 and still come out right. So this will be minus 1 both sides. So this is 2x equals 4, x equals 2. Here I've got negative 1. So 2x equals negative 6, x equals negative 3. So I have two answers. And if you put those back inside to the original problem, if I put a 2 in here, that's 5 times 2, which is 10. That works. Negative 6 plus 1 is negative 5. Absolute value of 5 times 2 is 10. So they both work. All right, so the assignment that we'll have in class will be based on these examples. So be sure you have this in your notes, and because I will be checking notes when you come to class. So I'll see you then.